The next step is we need to be able to attach our leaves that are currently missing to our branches. Now, one way to do this is to do it like with a vellum simulation, but that is a lot of leaves, and I don't think we would ever get it finished. The simulation would take forever. But maybe what's nice to do is you do some of them. So if you want some leaves to kind of fly off, simulate a few of them just so they break the constraints in the vellum simulation and come off. But I won't be doing that here in a future tutorial. I might be showing how a way to do that, but that's not too hard to do. What's more tricky is getting these instances that we have set up here and getting these to follow our RBD simulation in a pretty quick manner. So I'm going to quickly flag the leaves. I'm going to get a null. Just going to connect it up. Just call it in leaves. And I'm also going to make sure I turn off the wind enable just for the second while we set this up. Now the first thing I'm going to do is I'm going to create a blast node, connect that up to our file cache, just here, and I'm going to select the group leaf group and delete non-selected. So that comes from up here in the modeling tab on the section here which I instanced the leaves on the geometry here. I gave this level, the red level, a custom group called leaf group, which only applies to what I've generated here. It's still got this previous group which is used for generation, but we can use these custom groups to select and isolate areas which we want to do for other things. Like now we want to make sure we attach our leaves to the same level of geometry, like this leaf group just here. So next thing I'm going to do is I'm going to unpack this group, because remember this is all packed geometry. And I'm going to do an attribute delete. And I want to delete every attribute that is not ID on the point attribute. So I'm going to set it to ID and hit delete none. Next, I'm going to create a time shift. I'm going to delete the expression and set the frame to 1. Following, I'm going to create a point deform. Wire up the last one to the attribute delete, second to the rest, as the rest to the time shift, and then the time shift to the attribute delete as well, and this is what we're going to be using to deform our leaves. Next, I'm going to be duplicating this time shift. I'm going to plug it into my leaf null just here. I'm going to create an add, plug it into my time shift, and I'm going to delete geometry but keep the points. So this will just give us a point at the root of exactly where our leaves are. Following again, I'm going to copy this attribute delete and just paste it here. Wire it up and then wire that up to the point deform there. I'm going to flag the point deform. I'm going to set its min points and max points both to 1. I'm going to set the piece, I'm going to turn off rigid, compute normals, and I don't really want to do any of that, that's all fine. And I want to turn on this piece attribute to ID. So now I'm just going to quickly simulate this, and then I'm going to speed up through this part. Now let's just quickly play it back. Let's quickly do a merge node. I'll just bring it up to here actually. Let's widen this, and we can just see that they have attached and it's all working well. So the next step is we actually need to get our leaves attached to the points that we just cached, because at the moment these are just points. We actually need to get the leaves back there. So I'm going to create another time shift. Oops. Again, set that back to just 1. Create another point deform. Plug that into the rest point lattice, and then plug the 2 rightmost inputs into our deformer here. I'm going to set the radius to 0, minimum points at 1 and maximum points at 10, and I'm going to disable rigid and recompute normals and delete the attributes. Oh, I'll leave that on, it's fine. Following, I'm going to plug the mesh to deform up to our in leaves, and then I'm going to flag the point deform. And as you can see, this now actually deforms really quickly and follows those points that we just cached. Doing it this way where we cache points first and then do the point deformation again then after, I found was a lot faster, and it also allowed me the ability to toggle on and off the wind on my leaves very fast. So if I cached this here, then I was, oh, I want to slow down the wind on the leaves, I'd then have to recache this whole area. But if I'm still happy with this simulation, this way I can leave the cache here and just update the wind on the leaves just here. So right now if I just turn it back on, we'll see now, yep, the wind on those leaves just changed, and now the wind is still going. So I'm going to turn that just off for a second so I can see this all happening nice and quickly. I'm going to plug the merge, plug it into the merge, flag it, and just like that we have our tree with an RBD sim being destroyed. Okay, here we go. Alright, I hope this tutorial has been helpful. This file is also in an example file I've supplied in JZTrees under the examples folder in the root directory of the plugin. So I hope this has been helpful,